Good morning, I'm Méadhbh Brosnan and I'm going to present some of our recent ageing work. Older adults differ quite a lot in their capacity to maintain healthy cognition, both in the face of advancing age and with age-related neuropathological conditions. And understanding the neurobiological basis of this variability will help us develop better interventions for preventing and remediating decline. It is well established that older adults who have been exposed to more enriched environments through, for example, education, professional and leisure activities preserve high levels of cognitive function in spite of compromised markers of brain health. It is also increasingly well documented that response speed, or the efficiency at which an older individual can respond to sensory information, indexes vulnerability to cognitive decline. There are many examples of this in the literature, and I'm highlighting a particularly compelling longitudinal study here from Parminder Sachdev's group in Sydney. Here, in over 800 older adults, they show that response speed measures on simple decision tasks predicted a 50 to 60% increased risk of developing a full diagnosis of dementia over just a 4-year period. But response speed is the outcome of several neurophysiological computations in the brain, and we are yet to understand which processes account for the close association between response speed and neurocognitive health in aging. We set out to address this question here with 72 individuals, 41 older, with a bilateral variant of the bilateral or random dot motion task. We used EEG to isolate 8 distinct metrics. We looked at the N2C over occipitoparietal electrode sites as a marker of early target selection, the centroparietal positivity or CPP as an index of sensory evidence accumulation, its starting point or onset latency, build-up rate or slope, and decision threshold or amplitude. And we looked at beta band activity contralateral to the right-handed button press as a marker of motor preparation. Lastly, we measured levels of environmental enrichment in our older adults using a gold standard semi-structured interview called the Cognitive Reserve Index questionnaire. So we found that at the group level, aging was associated with slower response speeds. In line with previous work, we also found that high levels of EE, or environmental enrichment, offset age-related deficits in response time, suggesting that our measures of speed obtained with the random dots are sufficiently sensitive to pick up these previously reported associations. When we model response speed as a function of our EEG signals, we found that CPP build-up rate was not only strongly associated with individual differences in response speed, but it also influenced subsequent processes, namely CPP amplitude and beta latency, to additionally impact behavior in an indirect manner. Intriguingly, high EE individuals, here in orange, maintained fast response speeds in spite of compromised markers of evidence accumulation rate. These results are in keeping with the phenomenon of neurocognitive reserve and further suggest that evidence accumulation rate might index a critical aspect of healthy neurocognitive aging. Finally, we were curious as to the potential utility of CPP build-up rate as a translational tool. For each participant, we randomly selected 1,000 estimates of reaction time and CPP build-up rate for 6 different bin sizes, so from 20 to 120 trials. We found that strong effect sizes for this association between CPP build-up rate and reaction time were observed with as few as 40 trials, which can be obtained in just under 6 minutes. So our data show that CPP build-up rate likely holds meaningful information about healthy brain aging. In younger adults, we've recently shown that this metric varies according to organization of the dorsal frontoparietal networks, and in older adults, increasing excitability within this network improves markers of response speed. This begs the question of whether the results I just presented can be attributed, at least in part, to differences in the DFPN. I'd like to thank all of my collaborators on this project, and I look forward to your questions.